Chem 1. Very good. So this right here, if you'll trust me, learning this can help you with the thing I'm doing today, the new stuff tomorrow, today, and the stuff we did yesterday. You're okay on this? Now, I do want to mention a couple things that I didn't mention yesterday, all right? This is new. I want you to take a look. Down here, there's a story. Now, if you want to go home and read that story, you can, or you can just listen really carefully. These are all prefixes. They cannot stand alone. Now, for example, if I saw this, 8 little m, that could not mean 8 millis. There's no such thing as 8 millis, because a prefix can't stay by itself. It has to have something after, doesn't it? So what do you think 8m would mean? What? 8 meters. You ever get that? What if you saw this? 8 little m big L. What do you think that is? See, milliliters. In that case, the little m stands for milli, doesn't it? Because it's a prefix. Is everybody with me on that? Okay. Now, I want to show you two other things that are not prefixes. They are not prefixes, but they have to do with the story. There are science things that have to do with this chart. One of them is this thing called a micron. Now, this is down here. If you want to go home and tell yourself, I need to read that tonight, okay? A micron, if you become a biologist, you will probably go to a microscope, and you'll have you'll take the regular eyepiece out of the microscope, and they'll give you one that costs a lot of money. And in that eyepiece is the teeniest tiny ruler you've ever seen. It's so tiny. It measures in microns. And so if you want to measure a cell, you just move the eyepiece around until you get to the cell. And say, hey, that cell is 70 microns long and 30 microns wide. And you could actually measure something that is tiny, really tiny. And there are people who do this all the time with computer chips. They have special microscopes that have little rulers in them, little, and they can measure microns when they're doing computer chips and stuff like that. So microns is something that's going to be somewhere in your life, I think. Well, it just so happens that a micron is not a prefix, but it's a distance, and it equals the same as a micrometer. So I'm okay. There are some science people who use the word micrometer, and some of them that use the word micron. Everybody got that? But micron is not a prefix, so you can't say micron gram. You can't say micron gram. Can you say microgram? Can you say microgram? Look at me. Microgram? Can you do that? Yes. But micron gram? No. A micron is a distance unit, and it's 1/1,000,000th of a meter, isn't it? Didn't micro mean 1/1,000,000th of something? All right, and the other one, if you become a physicist and you want to study the atom, or you want to study the newest types of computers where they're trying to store memory at the atomic level, you might hear about a word called an angstrom. Okay, now what is an angstrom? And an angstrom is not a prefix, but an angstrom, there's the abbreviation right there, is 10 to the minus 10 meters. It would have been nice if atoms would have been the size of nanometers, but nanometers are too big. Atoms are smaller than a nanometer. So they made up their own word. It was called angstrom. And an angstrom is 10 to the minus 10 meters. So on the quiz, after I ask you to write the prefix and the abbreviation and put them on the right stair step, I'll ask you to put the name of two distance units that are used in science that we talked about. One of them's called a micron, and you know what's unusual? Here's what's unusual. Guess what they decided the symbol for micron was going to be? It's the mu symbol again. Now, what's the difference? Look at the difference here. Ready? What does M mean, and what does M with a dash after it mean? What does M by itself mean? Meter. What is M with a dash after it? Uh-oh. Milli. It's a prefix, isn't it? Now watch this. What is this mean? A mu symbol with a dash after it. And what does a mu symbol with no dash after it mean? What's a mu symbol with a dash after it mean? Micro, which means it's a prefix, isn't it? And what is the mu symbol with no dash after it? Micron, and that is a micrometer, isn't it? Now those are minor. That's very minor. I do want you to know about it. If any of you do go into science, you're going to hear micron, you're going to hear angstrom. Okay. So anyway, I think, did we do like, how many of these did we do yesterday? 5, 4, how many of these things? 5 of them, something like that? Okay, so let's go over here this side, all right? Did we do these? Okay. I bet we didn't do 11 though, did we? We did.
Well, some people did.
That was a hard one. Okay, so let's do number 11. 1 billion micromoles equals how many millimoles? Now, even though in the second semester you'll find out what a mole is, it's a very big important idea in chemistry. Now, you don't have to know what a mole is and said, okay, micromoles to millimoles. Where am I going? From what prefix to what prefix? What power of 10 is micro? Everybody. 10 to the 96, and where am I going? What's milli? 10 to the negative third. Okay, 10 to the negative 6. There's micro. I'm going to milli. 1, 2, 3. I saw my finger go 3 to the left. Now I have to move the decimal 3 to the left, right? But look at it. Where's the number? How do you write a billion? Well, let me think about that. What is a billion? 10 to the what? And how many zeros would it have then? Huh? Doesn't it have 12 zeros? Doesn't a million is 10 to the 6, right? Doesn't it have 6 zeros? A billion is what? 10 to the 9th? How many zeros? Okay, well, there's a million. There's a billion. Now, replace this with that. And the stair step said you have to do what to the decimal? What did it say? 3 to the left. I think you got it right. Who got it right? Is that the end of the period? You got it right? You're good. It was, you go 1, 2, 3, and these disappear. And what's the answer? 1 million. There you go. Man, if you can do that problem there, you know what you're talking about. And you didn't get scared with numbers. That's another thing I do this. I don't want you to be scared about the metric system. If you go into science or medicine, you're going to have it. It's going to be in there. And you can't say, I'm not going to be scared about it. Milliliters, microliters, you're not going to scare me of that. All right. Now, here's one I skipped yesterday because you didn't know what a micron was. Let's see if you can do number 2. Let's see if you can do number 2. And I'll tell you what, whoever's sitting next to, if you want to talk it out a little bit and say, how do we do this? All right, let's do that. And then I'll wait about 30 seconds. And I think you should have it done in about 30 seconds. 880 microns equals how many nanometers? The reason you're sitting next to somebody is so they can help Sean. Help him. Tom, help him. Talk to your partner. How do you do this? Who are you talking to? Who are you talking to? Talk to somebody. No, look at Charlotte. She's waiting for you to talk to her. Hey, look at you. Ready? All right, here we go. Number 2. Everybody got it? Now, the reason you talk it out is because some of you don't know what to do, and you talk to your neighbor, and they'll say, I'll tell you what to do. Nanometer. NM. Okay, now, if you think you got number 2 right, go to number 5. I put in a number for number 5. Got erased by the hole punch. Number 5, 860 angstroms equals how many microns? So we're doing number 2 and number 5. Number 5, I had to give you a number because I got erased. If you look on the screen, you'll see here number 5 is 860 angstroms equals how many microns? All right, talk to your partner. Do you think it's going to be important tomorrow in the quiz for you to know your powers of 10? You need to know your prefixes, don't you? Okay, we've been working on these for days. All right, are you ready? Everybody ready? Now, let's say that you had a partner, but you still don't know how to do it. How about that? Is that possible? Is that possible? Okay, let's take a look at number 2. Micron is in the same powers of 10 as micro, isn't it? The micron is 10 to the minus 6 meters, so I'm going to put it right here. Here's micron. And I'm going to nanometers. Nano, negative 9. Isn't that how you do it? Nano, negative 9. So I go 1, 2, 3 to the right. 3 to the right. So I take the number 880, and don't tell me there's no decimal in $880, right? Isn't there a decimal? It's there. But I have to do what to the decimal? Move a 3 to the right. 1, 2, 3. Raise your hand if you got 880,000. Okay, now, if you didn't, do you remember what happened? All right, this is a hard one. 860 angstroms equals how many microns? Where would you find angstroms? And I just taught it today. Yes, how do you know? I just taught it today. 10 to the minus 10 meters. That's over here. And I'm going to where? I'm going to microns. Where's that? 10 to the minus 6 meters. There we go. So I start at angstrom. Here's angstrom. And I go 1, 2, 3, 4. 4 to the left. 4 to the left. So let's take 860. Here's the regular number, 860, but I have to move the decimal 4 to the left. 1, 2, 3, 4. All right. Raise your hand if you got that one right. Ooh, I'm impressed. What if you missed it? If you missed it, did you not know where the decimal was for 860 or? All right, so do you think I'm going to have some of these on the quiz? The quiz is second half of the period tomorrow, isn't it? Second half of the period. All right, so what do you think? I think I know what the quiz looks like. He's going to make me do that. He's going to make me show where micron and angstrom is. Then he's going to give me maybe, I don't know, 4 or 5 of these. And you know what? I'm going to get them right. I'm going to get them right. And then we're going to do one more, and that's today's lesson. Now, today's lesson has to do, and I'm going to go back to this one more time. I'm going to go back to this chart one more time. If you trust me. And let's look right here. This is such a powerful thing. What I do know is that all of these numbers here are bigger than 1. Did you know that? Is 10 to the 6 a big number to you? 10 to the 6, that's like 1 million. That's big. Can you remember that? These are big numbers, aren't they? What about these numbers here? These are not negative numbers. They have negative exponents, so what does that mean? What kind of numbers are they? Starts with a D? What kind of numbers are they? Start with a D?
Decimals.
What?
Decimals.
Decimal numbers, aren't they? They're smaller than 1. They're not negative. They're between 0 and 1. They're decimal numbers, aren't they? All I need you to know, all I need you to do for me is remember that a negative exponent means you're a decimal, right? Can you remember that? If 10 to the 6th is a million, what's 10 to the minus 6th? Oh, man, I lost me there. If 10 to the 6th is a million, what's 10 to the minus 6th? A millionth. That's all I need you to remember. These are decimal numbers. You got that? Now I'm going to teach you something that I'm not going to teach it the way the book teaches it. I'm not going to teach it the way your math teacher teaches it. I'm going to show you how to do this, and you're going to say, that was easy. I wasn't taught this way. I was taught the way the math teacher did it. I had a book, and it said, even my science book did this. Here's on one page. Here are the 3 steps to put a number into scientific notation. On the next page, here are the 3 steps to take a number out of scientific notation. Well, because I was like you, I said, okay, I guess I got to remember those 3 steps, and I got to remember those 2 steps, and I better not mix them up. If I mix them up, I can miss them all. That makes me kind of nervous. So I'm not going to teach that way. I'm going to teach that way. Now, what is scientific notation? Have you had this before? Has any other class ever taught you about scientific notation? And if you want, it's in your book, isn't it? You can read in chapter 2. And here's what happens. Science many times deals with really large numbers, or they deal with really tiny numbers. But notice that whether you're really big or really small, they take up a lot of space, don't they? You know, it's also confusing. It's like, what if I don't put decimals in these? What number is that? That makes it very difficult to figure out what that number is. So scientists said, why don't we have a way to represent any number in a scientific notation form so you can quickly look at it and tell what it is. Here's one. What do you think? Is that a lot or not? Is that a lot or not? It's 5 what? What's that? What's that? That's 5 million. Oh, that's 5 million. See how fast that was? Now what about this? Is that a lot? No. Why? What is this? 10 to the 9th is a billion. What's 10 to the minus 9th? It's a billion. I got 5 billions. Is that a lot? No. Yes? Yeah, you know, with me? But I can tell you right away. What if I wrote that number out? It would be like this. What's that? Well, I don't know. But if I write it like this, it's 5 billions. It's pretty smart. It's pretty smart what they did. So, I don't want you, if you want to, if you're a concrete learner, I gotta memorize these steps. You can do this. You can go learn, okay? But I'll tell you on the quiz, if you do that and you mix them up, you'll miss every single one of them. What do I want? I want you to get every single one right. Let me show you how to do it. Can I show you how to do it? All right, what I'm going to do is, you see that decimal? I want you to move the decimal to create a number between 1 and 10, not counting 10. So you can create, I want to move that decimal. Now watch, if I move that decimal to here, 0.5, do you think that's between 1 and 10? Is that between $1 and $10? No, that's only 50 cents. So where do I have to move it? Do I have to move it to here? Okay, so watch. We're going to do all 10 of these at the same time. Ready? You're 5. What number would this be? Move the decimal to create a number between $1 and $10, not counting 10. What do you think? You want to move it here? No, that's 505. You want to move it here? No, that's 50.5. No. What do you think? Is this between 1 and 10, not counting 10? Yes? I do the rest of them. What's this one going to be? Let's see, between $1 and $10. What do you think? Help me out. 8. That's between 1 and 10. How about this guy? Gosh, that's a hard one. Darn. What is it? It's between 1 and 10, not counting 10. So what is it? How about the next one? Oh. Okay, next one. Wait, somebody said it. 2.5. That's between 1 and 10. How about the next one? Oh, I'm pretty good at this. Hey, what do you think? How about step 1? Step 1, create a number between 1 and 10, not counting 10. How about that? Can we do that? All right. Did you know, some of you realize this, when you move the decimal, that's called powers of 10. You're messing with powers of 10. Do you know that? I didn't know that. So you know what? I have to replace the powers of 10 that you were messing around with. So I put times 10 to that, times 10 to that, times 10 to that, times 10 to that. So step 2 is times 10 to that. What do you think about step 2? Is that pretty easy? Now, this is the only one you have to pay attention to, all right? You think, is that first 2 steps pretty easy? Okay, now watch. How many places did you move that decimal? when you moved it to create 5, how many places did you move it? Let's take a look. 1, 2, 3. I'm going to put that as my exponent. See that? And I have one more thing to think about. Watch now. This is the hardest part. I don't want you to go up here like the math book says. If you move it to the right, don't do that, because it'll let you down. Let me ask you this question. What kind of a number was this original number? Was it big or a decimal? Then what kind of an exponent does it have to have? Negative. That's -3, isn't it? Let's go to the next one. Ready? How many places did you move the decimal? 1, 2, 3. What kind of number is this? What kind of number is this? Big. Then what do I do with this? Keep it. That's big. This is a big number. This is a big number, isn't it? Next one. I moved it 1, 2, 3, 4 places. But wait a minute. What kind of number is this? Oh, you're a decimal. See? Look at this. That's a small number, isn't it? That's a small number. What do you think? If you do it like the math teacher or the science book, they'll tell you if you moved it to the right, negative exponent, but don't do that. I hate it on a quiz where I give 5 of them and you get them all mixed up. It should have been negative, put positive. Don't do that. Can you remember that 10 to the 6 is big? That's all you need to know, all right? What do you think 10 to the -6 is then? That's a decimal. Okay, let's do another one. What are you going to put here? What do you think here? Let's go around the room. Let's start back with Ben. Ben, what would you put here? 1 times 10 to the what? +3 or -3? Okay, this is a big number. See that? That's a big number. All right, next. Gabe. But that's a big number. Is this a big number? And you knew that 10 to the 6 was a million anyway, didn't you? All right, next. Sean, what is it? 1 and positive or negative? Look at me. Look out here. Is that a big number or a decimal number? He's small, isn't he? So what kind of exponents are we going to give him? Yeah. All right, next. Thomas.
10 to the 92.
Yes. Look, hey, Thomas, look at this. See that? That's a small decimal number. Oh, so is that. Well, you must have done it right. All right, next. Get it. But that's a small number. And that's a small number, isn't it? All right, next. Taylor. But are you going to leave it at 2 or -2? But that's a big number. Well, so is that. All right, next, J3. What do you think? Is this it's pretty simple? Now, is everybody okay on this? Now, can I ask you to do something for me now? I want you to watch. We're going to do down here, okay? Let's do the reverse. Let's do the reverse. Now, watch what I'm going to do here. See this? Look at that number. What kind of number is that? What kind of number is that? If it's in scientific notation, I can tell you what kind of number it is. What kind of number is this? A decimal. If I want to take a number out of scientific notation, I'm going to move the decimal 1 place. I know what you want. You want me to say left or right, don't you? I'm not going to do it. I'm not going to do it. All right. Wait, let me see if I'm frozen. No. Okay, ready? I'm not going to tell you left or right. Here's what I'm going to do. Move that decimal 1 place. But when you get done, what kind of number are you going to have? A decimal. So try it both ways. Move it both ways. One of them will give you a decimal. All right, everybody try that one. Wait, where we leave off? J3? All right, you want to try it? You think you're ready for this? You're going to move the decimal 1 place, but when you get done, it better be a decimal number. I'll tell you, you want me to do the first one, you do the next one?
Sure.
Let's do that. I have to move the decimal 1 place, and if I move it this way, it'll give me 33, and that's not a decimal number. So what am I going to do? I'll move it the other way. What do you think? Look at this. Is that a decimal number? Is this a decimal number? I think I did it right. Okay. Are you ready now? Okay, all right. Which one do you want to do? You pick it up. You pick number. I'll let you pick it.
Number 7.
7? All right, go.
You're gonna do the decimal point corresponds.
Wait, are you doing 7?
Yeah.
Okay, go ahead. Decimal point what? Oh, are you doing 7?
Yeah.
Can I tell you the answer is going to have a 1 and a 2 in it? It's going to have a 1 and a 2 in it. Okay, what do you got? Point what?
0, 0, 1,
What do you think? Let's take a look. You had to move the decimal how many places?
2.
4.
That's another 0.
Huh?
There's another 0.
Okay, another one right here. Let's take a look. She had to move it 4 places, and when she gets done, what kind of number does she have to have? A decimal, right? So she starts with 1.2, and she has to move it 4 places to get a decimal. 1, 2, 3, 4. That's right. You did it right. Now, you know how you can double check? How do you double check your work? Let's put this into scientific notation. What do you get? Ooh, 1.2 times 10 to the what? Negative what? Negative 4. Yeah. All right. Ready? Matthew, pick any one you want. Not number 10. That's too easy.
Number 10.
No, don't do that one. That's too easy.
I did number 3.
All right, I'm ready.
0.0375.
Wow, that was fast. You knew you had to you had to move the decimal 2 places, right?
Yeah.
And when you get done, what kind of number are you going to have? What is 3.75 times 10 to the minus 2? What kind of number is that? It's a decimal. What do you think? Good job. Next. Which one? 8? You want to do 8? I can't hear you. 4? Okay. I'm ready. A little bit louder, sorry. I'm not going to say left or right. I know you have to move it 2 places, but when you get done, what kind of number are you going to have? What kind of number is 3.75 times 10 to the second? Is that a decimal number or a big number? What's 10 to the 6th? Is 10 to the 6 big? Is 10 to the minus 6 big? No. Is 10 to the second big? All right, move it 2 places. When you get done, you better have a big number. That's why I don't want you to say left or right. I don't want you to say left or right because you'll mix them up. You see? What you got? Yes, yes, yes. Everybody see that? She had to move it 2 places, and when she gets done, it's got to be a big number. Well, you better not move that way. Go over here, right? All right. Lonnie, pick one. By the way, I'm going to do number 10 for you because I don't want you to pick it. Does anybody know what this one is? It is, because anything to the 0 power is what? And what's 1 times 4? Okay, all right. You can either write as 4 or 4 times 10 to the 0, either one. If you want to write as 4 times, I'm sorry, take it out. Okay, it's 4. All right, Lonnie, pick one. You got 1, 2, 5, 8, 9.
Number
1. All right, I'm ready. Ooh, what kind of number is that, Lonnie? What kind of number is this? Is that a big number or is that a decimal? It is big. So you had to move it 3 places to make a big number, right? 1, 2, 3. Is that what you had? So I had 1.5, didn't I? I had to move the decimal 3 places. 1, 2, 3. And I think it's 1,500, isn't it? 1,500. All right, you ready? Luke? You got 2, 5, 8, 9. 2. Hey, Luke, what kind of number is this? Huh? Decimal number or big?
Decimal.
Oh, yeah.
So it's 0.0015.
Wow. You guys are fast. I'm going to double check your work. 1, 2, 1.5 to 10 to the minus 6. Yes. All right. Hayden, you ready? You get 5, 8, or 9?
9.
Okay.
0.1.
But you knew 10 to the minus 1 was 0.1 anyway, didn't you? Isn't that 1/10? It is 1/10. Anyway, this is a decimal number. You had to move the decimal one place, and there we go. All right, next, Charlotte. You're number 8. Okay, 8. 10,000. What is 10 to the third? Now look at me. What's 10 to the third? 1,000. What's 10 to the fourth? Yes. So anyway, you knew that, and I'm glad you knew that because that is the answer. You had to move the decimal 4 places to make a big number, and you did. 10,000. Again, if you ever have a teacher trying to teach you the way they do the math teacher, even the science books do it, that lefty-righty stuff, I wouldn't do it. I wouldn't do that. Okay, last thing I want to show you, this would be a bonus question. If you would like to do some bonus questions, okay, I have a bonus question for you. It'll be something like this. All right, 865 times 10 to the, okay, now, what if you see something like this, and the directions say, if the number is in scientific notation, then take it out. If the number is not in scientific notation, put it into scientific notation. Now, what are you going to do about this guy? Are you going to say, it's already in scientific notation? Is it or not? Why is it not in scientific notation? What? Yeah, it's not between 1 and 10, not counting 10, is it? So let me show you. This will be a bonus question, okay? Bonus. And this is a little higher level. You okay with that? Higher level? Okay? I'll show you how to do this. Ready? Imagine you don't see this part, and just put this in the scientific notation. Put 865 in the scientific notation. Go ahead and do it now. Put 865 in scientific notation. Write it down. Just the 865 part. What is it? 8.65 times 10 to the what? Huh? To the second? Okay, now, the thing you covered up, put it back. Now, I'm not your math teacher, but I bet they taught you this. When you multiply numbers with exponents, what is x to the second times x to the third? What do? You add the exponents. So what is 10 to the second times 10 to the third? Everybody okay on that? All right, let's do one more. I'll do one more bonus question, and it'll be something like this. Okay, is that in scientific notation? No, first part's not between 1 and 10. Go ahead. Put this number into scientific notation. I'm going to be very proud. If you can do this right here, I'll be very proud of you doing this. This is a little bit higher level. So act like you don't see this and just put this number in scientific notation, okay? That's a decimal number, isn't it? So what is this one? 6.12. 1, 2, 3, 4. Is that positive or negative? What am I going to put here? Okay. See that? And now I put this back down where it belongs. Final answer. 6.12 times 10 to the what? What it? -7. Ooh. What do you think? Now, we're not taking a quiz the first part of the period, are we? So what are we going to do? We're going to review tomorrow, aren't we? And we'll review scientific notation. We'll review putting numbers into scientific notation, taking them out. We'll review anything you want to review, okay? But try to get yourself ready for a quiz. I'll tell you what, if you know your prefixes, you're in great shape. You're gonna be in great shape. All right, well, thank you very much. I'm done.